In this video, we'll be looking at the next method of evaluating a limit analytically. So the first two methods was direct substitution, or simply plug in the value. The second method was factor and reducing. After this, we're looking at methods that we're going to have to utilize in order to simplify the limit. Now you'll notice in the example that you have on your notes is that this limit doesn't have the parentheses around it. But we should note that this is the limit of this entire function. So I, for simplistic sake, put those parentheses around it. Now, as long as I make algebraic manipulations within those parentheses, there is nothing mathematically wrong with what I'm going to do, and as long as I use all appropriate methods of simplification that are algebraically fair. In this case, what I'm going to do is I'm going to realize that this entire thing right here with the addition is on top of the function. And this right here is technically on the bottom. Making that note, telling me that I have this on top and this on bottom, tells me that I can rearrange the order of this fraction so that I have 1 divided by 4 plus x times 1/4 plus 1 over x. Because this is exactly the same thing, such that I multiply this stuff on top. And again, that's how fractions work. When I multiply two things together, if I have something that is not technically on top of a fraction, I can move it to the top of the fraction, multiplying it by everything on top. The best simple example of this is 4/5 is the same thing as 4 times 1/5. So this, in this case, behaves like the 4, and this behaves like the 1/5. So once I've done that, it makes it a little bit easier to handle. Also notice I put brackets around the whole thing, emphasizing that it's still the limit of this entire function. The next method we're going to apply, again, we have factoring and we have direct substitution, and I didn't check it, but you'll notice when I plug in -4 back in here, I'm dividing by 0. And dividing by 0 is mathematically inappropriate, and therefore I cannot evaluate this limit as it is. So, I like to call this 4 plus x term the problem child. It is the thing that has to go away in order to make sure that this limit can actually be evaluated. So what I'm going to do is I'm going to leave that 1 over 4 plus x alone, and I'm going to just try and simplify this piece right here. In which case, I'm going to leave 1 over 4 plus x alone, and I'm going to go ahead between these two fractions, and how do I combine these two fractions? By addition, I'm going to find a common denominator. I'm going to do that off to the side here because I think things are going to get a little bit messy if I try to do it all together. So I have 1/4 plus 1 over x. The 1/4 I'm going to multiply, the 1 over x I'm going to multiply at 4 over 4, and the 1 over 4 I'm going to multiply by x over x. In doing so, it provides me with x times 1, which is x, plus 1 times 4, which is 4, and both of these denominators are now 4x, 4x. So since I have one common denominator between these two addition pieces, I can simply write 4x in the singular denominator. This allows me then to say that this fraction addition is the same thing as x plus 4 divided by 4x, and now you'll notice that 4 plus x and x plus 4 are actually the same thing, meaning that the limit as x goes to -4 of this thing here is actually the same as the limit as x goes to -4 of 1 over 4x. Can I plug in the -4? And the question is, what is 1 over 4 times -4? Well, since it's -1 over 16, this numerical value tells me that the limit as x goes to -4 of this function is actually -1/16. This is the method of using a common denominator to evaluate a limit.